Hello everyone. So today we are going to do one very important name reaction, or I would say a very important reaction, okay, of organic chemistry. Now all of you have faced some difficulty in the different reactions in organic chemistry. So what we started from today, that there's a name reaction series. Okay, you face many difficulty of remembering the name reactions, how to solve the problem and all. So उसको ध्यान में रखते हुए हमने आज से एक सीरीज स्टार्ट किया, दैट इज अ नेम रिएक्शन सीरीज. और टुडे वी आर गोइंग टू टॉक अबाउट द एरोमेटिक इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शन, जो क्लास 11 में इन द चैप्टर हाइड्रोकार्बन, एरोमेटिक हाइड्रोकार्बन इट इज देयर. Okay, so let's start. Now see, when I say aromatic electrophilic substitution, सबसे पहले हमें दिमाग में आता है what about benzene, right? So let's write the structure of benzene first. Okay, it's a aromatic compound because according to the Kekulé, it actually gives you follows the 4n plus 2 pi electron rule. Number one, it is a planar geometry, and it is also have all the carbons sp2 hybridized. Okay, so which actually makes the whole benzene system as an aromatic compound. Now see, benzene is something sea of electrons, we can say, and it has complete electron cloud roaming around in from each carbon to another carbon. Now in this case, if you react a benzene with an electrophile or a nucleophile, it will prefer the electrophile to be reacted with rather than the nucleophile, because a nucleophile is a negatively charged species, right? So a nucleophile, if I write, it's a negatively charged species. Now if this nucleophile attacks here, the benzene, there will be an electron repulsion will be there. So nucleophile will not be attacked. But if I talk about an electrophile, which is a positively charged species, and क्या होगा? The electron can easily attack the electrophile. Now once the electron attacks the electrophile, कुछ एक होता है. Let's see what happens. Now in the steps of the aromatic electrophilic substitution, सबसे पहला step जो होता है, it's very important, that is the generation of the electrophile. देखते हैं. So first step we are writing for the generation of electrophile. For the generation of electrophile. Okay. Now अगर हम देखें generation of electrophile, so बहुत सारे electrophiles, कुछ एक electrophile का हम नेम लिखते हैं यहाँ पे, जैसे कि like your NO2 plus nitronium ion we can write, or we can write CH3 plus, that is your methyl cation is there, right? So there are a lot of और हमें ये भी चीज पता है कि in a reaction when the NO2 plus reacts with the benzene ring, that reaction is called nitration. In presence of the reagent is concentrated nitric acid and concentrated sulfuric acid. Similarly, CH3 plus is a reaction of something called alkylation reaction of benzene, or we know specifically it's called Fiedler-Crafts alkylation, और जहाँ पे the reagent is used CH3Cl in presence of anhydrous aluminum chloride. Okay, हम ये reaction देखेंगे अभी. So the first step is your generation of the electrophile. पहले देखते हैं the reaction, nitration reaction का mechanism. Okay, चलो. So first reaction what we will talk about here, the nitration reaction. Okay. Nitration reaction. चलो. अच्छा, nitration. अच्छा, in case of nitration, what is the reagent we use? Here the reagent we use concentrated H2SO4 and concentrated HNO3 and heat. Definitely heat is also one of the very important reagents. We have to heat the system. Now together what they do, if I think in this way, थोड़ा सा अगर हम ध्यान से देखें यहाँ पे क्या हो रहा है, your sulfuric acid, this is your H2SO4, structure of H2SO4, okay, and this is your structure of nitric acid. Okay, अब सबको एक चीज पता मतलब कंफ्यूजन लगता है कि when we are mixing two acids, how they can react. But remember always one thing, when the two acid we mix, in that case, the one which is stronger, that will act as an acid, and the one which is weaker, that will act as a base. But so in this case, your sulfuric acid is a strong acid and nitric acid is comparatively weaker compared to the sulfuric acid. So nitric acid will behave as a base and sulfuric acid will behave as a acid. So ऐसे होने से क्या होता है? ऐसे होने से, now since a base, what a tendency of a base to accept the proton. Now, so it has a electron here in oxygen, so this will capture the proton from the sulfuric acid and it will return the O minus. So what it basically generating? यहाँ से देखो बेटा generate होता है, अगर हम इस हाइड्रोजन को यहाँ से हटा दें, so it will be forming HSO4 minus plus, अगर हम इसको ध्यान में रखते हुए देखें तो it will be H2O plus nitrogen with oxygen here, और ये यहाँ पे easily, और the water will come out from here, और इसके बाद what will be the product? The product will be NO2 plus. So हमारा nitronium ion ready, हमारा nitronium ion ready, right? Okay, अब देखते हैं next step. Next step is what? Attack of the benzene ring, attack of by the benzene ring to the NO2 plus. So हमारा पहला step we have did. What is the did? This is the generation of the electrophile. Next step. अब step number 2. Step number 2 में क्या है? Attack. Attack. Right? Okay. अब attack हम जो करेंगे यहाँ पे, see, so we have a benzene ring. We have a benzene ring, और यहाँ पे मैं हमारा है NO2 plus. NO2 plus, right? Now NO2 plus, now see, this is an electron deficient species और ये electron rich species. So what will happen? The electron rich species will attack the electron deficient species like this, correct? और पहले step में क्या होगा? Since this benzene is donating its pi electron at the first step to the NO2 plus, so it will form like this. Okay, so in the first step, what happens? The benzene is donating the pi electron density to the NO2 plus, right? So this is called, this complex is called pi complex. It is relatively unstable, but it has been isolated for few cases. Okay, acha. Now next step, what happens? At the next step, this NO2, sorry. At this next step, this NO2 is basically bonded, gets bonded with the benzene ring through the sigma bond. And what it forms? Like this. Now you can think in this way. Dekho, this system was aromatic, correct? And this system is non-aromatic compound, right? Because there is an sp2 carbon here. It's a non-aromatic compound. So when it is going from aromatic system to a non-aromatic system, the stability decreases. So you can say that it's a unstable, it's a stable system. Benzene was a stable system and is going to unstable system. So you can think that then how it is possible? Definitely is possible. This, once this non-aromatic compound is formed, this molecule is stable, but not aromatic. In terms of aromaticity is not stable, but in terms of electronic effect it is stable. And since it is going from an aromatic system to a non-aromatic system, you can say that this formation of this step is the slowest step. So that is why if someone asks you that what is the rate determining step of an electrophilic substitution reaction, you will say that attacking by the electrophile to the benzene ring, that is the RDS, or the rate determining step of the reaction. Okay, now say, as I said that this molecule is stable, so we can easily say that here, right, due to resonance the molecule is stable. Right, this one, then again, okay, then this will come here, okay, then Okay, like this. So these are the canonical structures, right? The canonical structures of the benzene with NO2. And here the benzene has formed a sigma bond with NO2. That is why this molecule, this system is called a sigma complex. This system is called a sigma complex, right? So our second step is done, right? Now for the next step, अब NO2 तो आ गया, right? Now it has to stay. लेकिन what we have to do? ये जो हमारा हाइड्रोजन है, this hydrogen atom, this hydrogen has to go, है ना? This hydrogen has to go. So क्या होगा हम देखेंगे? तो next step. So next step, step number 3. Step number 3, your formation of product. Formation of product. यहाँ पे क्या होता है? देखो बेटा, यहाँ पे once this molecule is formed, once this molecule is formed, okay, now you remember, हम थोड़ा सा पहले जाते हैं, देखो, remember this guy, that is HSO4 minus, वो still, that is still there in the reaction medium. Okay, so what is his role? Let's see. Now this HSO4 minus क्या करता है? This HSO4 minus acts as a base, because we know this is a very good conjugate base, right? It's a very good conjugate base. So it actually captures the hydrogen, and as a result क्या होता है? As a result, this electron reverts back. This electron reverts back. So what is the final product? So what is the final product from here? देखते हैं final product. So for the final product, what we got here is basically your nitrobenzene, correct? In addition to that, we already got our back the sulfuric acid. Now if you see here very carefully, one very important concept is here, is that when we started the reaction with the sulfuric acid, right? We started with the sulfuric acid, and at the end of the reaction also we are getting back the sulfuric acid. Then if I ask you that what is the role of sulfuric acid, okay, your answer should be in nitration reaction, sulfuric acid is acting as a catalyst, whereas nitric acid is acting as a nitrating agent. Nitric acid acting as a nitrating agent. Okay, so hence our nitrobenzene is formed, and from where the nitrobenzene is formed? From the benzene, right? So this is one of the, this nitration reaction is one of the classic example or a classic name reaction, you can say, of your aromatic electrophilic substitution. Okay, so that's all from the first part of the aromatic electrophilic substitution, or in the first video lecture of the name reaction series. So next onwards we will talk about more name reactions, more substitution reactions, more rearrangement reactions, more elimination reactions, and specifically हम लोग बात करेंगे name reactions के ऊपर. Okay, so till then all of you take care, bye, पढ़ाई करो, और if you like this video, subscribe, share with your friends, and most importantly that do a revision before your revision in organic chemistry before your examination. Okay, so if you have any comments or anything, any suggestions regarding or any concepts or any doubts, feel free to write on the comment section. Okay, so bye everyone, take care, thank you.